Well, hello, everybody, and welcome to the March installment of Science Communication Lunch and Learn, or SciComm Lunch and Learn. Happy St. Patrick's Day to everybody. I won't subject you to my terrible attempt at an Irish accent, but I hope you're all enjoying your St. Patty's Day. My name is Jory Weintraub, and I'm the Science Communication Director with the Duke University Initiative for Science and Society, which is the sponsor and host of this monthly SciComm Lunch and Learn series. For those of you who don't know, SciComm Lunch and Learn is a monthly series where we try to explore interesting, unique, novel aspects of science communication. We try to run these events as sort of a science cafe format, which means we generally keep the formal presentation part to about 30 minutes and leave lots of time for Q&A. So we hope that you will have lots of questions for today's speaker and that you will put them in the chat room. I encourage everybody to use the chat room to share your questions, and we'll try to get to as many of them as we can. I'll introduce our speaker in just a moment, but first I just want to give a quick mention of next month's SciComm Lunch and Learn. We have one more that we're going to do this semester. It'll be next month on April 15th. After that, we will take our annual summer break, and then we have a great lineup. We're already working on a great lineup of sessions for the fall. But next month, next April 15th, we're going to be doing something a little bit different with SciComm Lunch and Learn. We're going to have, as a guest, we're going to have Bradley Elf, who is at North Carolina State University, and he's a friend and colleague of mine. He is an evolutionary biologist and a poet. And he's going to be talking about the interface of science and poetry. And his session will be called Science Sonnets, the Poetry of Good SciComm. And just for fun, we thought what we'd try to do is give all of you a chance to share your science poetry as well. So we're going to invite people to write a science poem. It can be a haiku or a sonnet or a limerick or a free verse, whatever you fancy. And submit it, and we're gonna pick some of them and ask you to read them and share them during our SciComm Lunch and Learn next month. So it should be a really fun and different format for what we normally do. So I'll put the link to the website in our chat room, and you can go in there and sign up to participate next month and also submit your poem if you would like. Okay, well, on to today's speaker. Today we have Sara Kobilka with us. Sara has a really diverse and fascinating background. So she's worked in journalism, as a broadcast meteorologist, in informal science education, nonprofit management, science communication and outreach, and even as an instructor of fitness classes. She is currently also the owner and principal consultant of Renaissance Woman Consulting, and I'm sure she'll tell us a little bit more about that as well. I first met Sara a few years ago, I think, at a conference we were both attending. And as I learned more about her background, both in science communication and TV meteorology, I thought that it would be really cool to have her be part of SciComm Lunch and Learn and talk about communicating science and scientific uncertainty in TV meteorology. So with that, I will thank Sara for being here today and hand it off to her. And Sara, please take it away.
Awesome, Jory. Well, thank you so much. I am delighted to be here today, and I'm going to take over and share my screen so you can see what I've got going on. I had trouble sleeping last night because I was so excited, because this is the kind of stuff I really like to nerd out over. So, do I need an umbrella? Lessons from communicating science uncertainty from TV weather forecasting. That's what we're talking about today. So the things I'm going to be going over, I'm going to give you a little bit more information about my background. I'm going to talk about weather forecasting itself, some challenges that come up because we're forecasting for TV, strategies that are used on TV, and suggestions on how those strategies might translate into other fields where you're communicating uncertainty, and a bonus tip that has nothing to do with uncertainty at the very end. Full disclosure, I'm not on air anymore. This is an image from back in the good old days. I worked at 3 different stations, KOMU in Columbia, Missouri, where I was working on my broadcast journalism, Bachelor of Journalism degree. Then I transferred to UW-Madison and got my atmospheric and oceanic science degree. And after graduation, worked at WXOW in La Crosse, Wisconsin, weekend weather and weekday reporting, general assignment, so I covered whatever they needed. And then finally, ABC5 in Des Moines, Iowa was my last position on air. That was where I served as morning and midday meteorologist, and I was able to convince them with quite a bit of nudging to let me do a few science stories as well, because that's always been a passion of mine. And after I got out of TV, because I was sick of getting up at 2 a.m., I continued to have SciComm as a big part of my life. So I worked at two different science museums, the Science Center of Iowa and Flandreau Science Center at the University of Arizona. While in those programs, I was involved with the Portal to the Public program, which some of you may know from SciComm training. I ran our Café Scientifique program, so worked with a lot of scientists who were giving these informal talks. I also worked at two different universities, UW-Madison Institute for Chemical Education, and again at the University of Arizona, I was at the STEM Learning Center, and that was where Jory and I first met during my work with what was then NABI, now called ARIS. And I also got to continue to work with NABI and co-host the very last summit that was hosted under that name. And just for kicks, I also did a Master's of Science in Science Education while working at the University of Arizona, and it was a virtual program through Montana State University Bozeman. So I come about this with experience from a lot of different areas and kind of try to incorporate that. So first thing I'd like to do is let's make it interactive, woohoo, because I couldn't do that on TV. So I want to know, where do you normally go? What's your primary resource just on like an average day for getting your weather forecast? Because I'm sure many of you are quite weather nerdy folks. Nerds unite, weather is awesome. I call it the gateway drug to STEM because I can talk to 3-year-olds and 93-year-olds with dementia about weather, and it's a very tangible thing. So we'll give a few more seconds for people to vote on where is your favorite go-to place to get your daily weather forecast. And if you put other, if you want to throw your answer in the chat, feel free to go ahead and do that. Okay, let's end our poll and we'll let you see what's going on. So we're seeing our most popular are other weather apps on probably your devices. National Weather Service website or app is number 2. And then our third place looks like it's local TV and radio. Now, this is pretty representative, I think, of who the audience is. If we were polling a group that was maybe older, perhaps people with lower education, we would see that local television and radio are probably going to be higher percentages of their where they would be getting their weather. And to show you really quickly, a fun little fact I found when I was looking up all this information, the US Department of Commerce found that the majority of Americans check the weather forecast 3.8 times per day, which means, yes, there is an interest in weather and there's actually a relative amount of familiarity with weather, which is unique compared to some areas of science that we're communicating. But not everybody knows exactly where weather forecasts come from, so I'd like to share this, and just to make sure that you are able or that everybody's kind of starting at the same point of knowledge.
Every morning, millions of Americans wake up with the same question: what's the weather going to be today? All day, every day, weather information is updated to create timely and reliable forecasts around the country. But where do weather predictions come from? Every weather forecast begins with millions of bits of NOAA data. NOAA weather satellites observe the Earth's clouds and atmosphere from space. These satellites continuously scan the surface of the Earth, collecting data about the atmosphere, land, and ocean. The data is transmitted to NOAA's Satellite and Information Service, where a team of scientists and supercomputers process it through complex algorithms. Weather forecasts rely on data from satellites combined with measurements from the land, sea, and sky. The information is fed into weather models that run a series of complex equations used to predict future weather patterns. NOAA's National Weather Service then analyzes this data. NOAA provides weather data and information to the public and private sector, who all use free, reliable NOAA data in their forecasts, which come to you through your local TV station or wherever you get your news.
We're going to pause right there. So I thought for people who are really interested in SciComm, it's an example of some very nice computer animated SciComm going on there. One thing that it doesn't really get into, though, is something related to the nuances of TV weather forecasting. When you are a TV weather forecaster, there is no requirement that you have to take what the models from the National Weather Service are putting out as information about the forecast and use that. You can use your own discretion. So that kind of makes it a little bit of a more unique situation. But let's go back. Let's talk about weather itself and whether and where areas of uncertainty come into play when we're talking about weather. And WX is the acronym that we use for weather. So one of the biggest areas where we're talking about uncertainty is related to probability. So yay, time for another poll. So this is, a little pop quiz. So I'm interested in seeing what is your answer to what this means. This afternoon's weather forecast says 20% chance of rain. Okay, so what do you think this means? We've got a number of different options there, and we'll give everyone just a little bit of time. I know it's quite a bit of text to read. You will be judged by no one, but it'll be interesting to see what the results are as we get done with this poll. And actually, I even saw an article just a couple of days ago. I guess there's a TikTok video, which I did watch, related to this very topic. Okay, we'll give you just a couple more seconds. This afternoon's weather forecast is 20% chance of rain. What does this actually mean? Oh, interesting distribution of answers. Okay, let's go ahead and end our poll, share the results with everyone. And what we found is the most popular answer is the third one. 20% of the time in the past, atmospheric conditions similar to this afternoon have led to at least 0.01 inches of rain. Second most popular is the answer number 2. So we're going to stop sharing our results and jump to our next slide. And let me show you what I think are actually 2 answers that are correct. And here's the reason why. I think that E is actually the most correct, as long as you're not necessarily going directly to the National Weather Service's app to get your weather forecast, because National Weather Service has a specific meaning of what 20% chance of rain means. But again, there is no requirement for other people who are putting out weather forecasts to use that exact definition from the Weather Service. And in fact, not even every meteorologist understands what the National Weather Service's forecast when it says 20% chance of rain really means. But when we're talking about atmospheric conditions similar to this afternoon's, there we are talking about weather models. And so when you talk about what that percentage means for the National Weather Service, that's called POP, the probability of precipitation statement. And at the very bottom, if you look, they're trying to explain what that means. So in this example, there's a 40% probability for at least 0.01 inches of rain at the specific forecast point of interest. My feeling is that's a non-answer. That actually doesn't mean anything when you read that sentence. So the question becomes, does this matter? And we say, oh, wait, no, we're scientists. We need accuracy. We need things. No, when we're talking about, especially for a TV meteorologist, but in meteorologists in general, what really matters is that your viewer, your audience is able to get enough information from the forecast you're giving to make decisions. Do I wear a jacket? Do I need my umbrella? Do I want to take the dog for a walk right now? Those are the types of tangible things. So if they don't know the exact official definition of the National Weather Service, it doesn't really matter. So looking at another area of uncertainty in weather, and that's localized events versus broader events. My favorite example of something like this is thunder snow. If you've never experienced it, it's a thunderstorm basically that is occurring, but what's falling from the sky is snow, and you can get really high amounts. You're getting 1 to 2 inches of snow per hour coming down, and that means that over a short distance scale, you can have one area that's going to just get clobbered and another area that doesn't have very much snow. And that is an area of uncertainty because if the storm moves just a little north, just a little south, that can really change those things a lot. You also have variability of weather across a forecast area. So here's my adorable family before I had my second child. She was on the inside at that point in time. And this was from 2 summers ago when we used to actually be able to travel. And we were near Estes Park in Colorado. We had been camping and we were camping in Estes Park. And then we went up the mountains and we literally encountered snow in the month of June when we were up in the mountains. And it wasn't a very long distance. And both areas that we were in were covered by the same TV station probably. And so when you're talking about a TV station that has a lot of area that they have to cover, you have a problem because time is the number one challenge for TV. There's only so much time. Your average, back when I was on air, our average regular weather forecast was maybe 3 minutes and 30 seconds. And that was the main part. And there was also an earlier time where we had a little bit of time to talk about the weather. So if you've ever heard the term DMAs, that's designated market areas. What that means is this is the area that particular TV station or those TV stations officially cover. So we can see the colors here. East Coast, a lot smaller, but if you look off to the west, for example, if you take New Mexico, that blue color covers most of the state of New Mexico, which means that TV stations in New Mexico are covering a huge geographical area when they're talking about the weather forecast. And not only that, but they're talking about a large geographic area that has a lot of topography, a lot of mountains, and that valley and that mountaintop are having very, very different weather forecasts. Now, this map is from 2013. I tried to double check and see if it's changed. I don't know if it's changed since then, but still, we can certainly see that this could be very challenging. When we have our time issue, you also have what graphics you're using. You have a 7-day forecast. You're supposed to be getting in 7 days of weather over an entire viewing area, and you only have one spot to put Sundays high and one spot to put Sundays low. So that's another area where there might be some uncertainty involved, but because of the nature of the actual graphic that you're using, you're not able to really portray that. You also get some mandates from management and the public, or perhaps the management's perception of what the public wants. So this is a quote. I reached out to a few friends in the meteorology field, and Steve Decker, who is one of my TAs when I was an undergrad at UW-Madison and who's at Rutgers now, noted that the audience and general public, or again, more importantly, many news directors, want it cut and dry, yes, no. And he gave an analogous situation with COVID. So most people want to know, is something safe or not safe? And that middle ground is a little bit difficult. Now, that isn't necessarily quite as accurate, though, when we're talking about weather. And one of the best articles that I came across, and I went down the Google Scholar black wormhole researching this topic because I think it's so interesting. So Communicating Uncertainty in Weather Forecasts, a survey of the U.S. public was one of the best resources that I found. And there is a resource document that I created, and Jory's going to be sharing that link a number of times with you today. But in this particular publication, they took a survey, a very wide swath of people from across the country. And here's a few of their key findings. 95% of the people who were surveyed, when they were given a single value forecast, inferred a range. So if they were told that a forecast said the high was going to be 75, they expected that maybe 74 could happen, 76. This isn't saying exactly what the range was, whether it was skewed one way or another, but just by the fact that people expect there is a range of possible values means that they have an inherent understanding that uncertainty is involved. 90% of the people also had decreasing confidence in later forecast times, that the forecast for tomorrow is probably more likely to be on target, and something for 7 days out, that is maybe something that you have to take with a little bit of grain of salt. And that is also true. Statistically, we know that the closer we get to a time, the better we are at forecasting for it. Highest confidence value changed, the amount of confidence that they had changed depending on what they were looking at. They were most confident in the temperatures that they were given, less in the precip chances, and least confident in the precipitation amounts. And yet again, this is actually mimicking fairly well what we know about what thing is more uncertain when we're doing weather forecasts and what thing is less uncertain. And finally, they gave an example where there was weather that wasn't following a quote normal trend. For example, you got a cold front here. It's going to be arriving sometime in the midday. We're expecting it to come through Raleigh. If it comes across at, say, 4 o'clock in the afternoon, then, oh, it's going to be hot, sticky out there, high in the upper 80s. But if that thing comes maybe 2, 3, 4 hours earlier, we're going to struggle to get out of the 70s, and it is going to be a huge difference once that blows through. Okay, well, in that instance, when there is that complexity and something's happening that isn't just our normal, it's going to keep climbing, and then in the afternoon, evening, it's going to be at the peak, and then the temp is going to go down. People actually like to receive an explanation of these weather situations as part of that uncertainty explicit weather forecast. And the authors of this publication note that this interest in explanation is corroborated by the popularity of television weather forecasts because of the power of what you can do when you're a TV weather forecaster. And we'll get into that in a little bit. Another thing with uncertainty in TV that you have to deal with is good old psychology. I reached out to my second chief meteorologist I worked under, Dan Breeden at WXOW in the La Crosse, Wisconsin area, and he noted there's a disconnect between humans' determinism and the weather forecast probability techniques. You give them a probability, but people hear that it's either going to rain or it isn't. And in their mind, if you give them a 50% chance of rain, well, then we're just probably guessing, and they question our credibility. In reality, that may be the limit of our capacity in that particular case. And I highlight credibility because that is a huge, huge factor. People know and have this sense of trust for those meteorologists they see on TV. We used to talk about how it's like you get invited into their living room, into their kitchen, into wherever they're watching, in their bedroom sometimes. You're invited, they're inviting you on a daily basis by watching. You're sharing who you are as a human being, not just giving the weather forecast. But if you have this credibility question and it's perceived by the audience that, oh, we can't trust them, they're not very accurate, that is an important thing that you lose, and you lose viewership. And TV is about eyes and people watching and commercials. So that is something to think about. So let's talk about what strategies are used for those TV forecasters. And one is to build uncertainty information into the graphics. And I'm going to show some images from a number of the stations in your area because I don't want to be seen as promoting one station over another. So this is WRAL. And at the very bottom, you can see precipitation. You have percentages, 90, 80, 50, 30, 30, along with a line that's showing that decrease of the percent chances of precipitation. So this is an example of one way that it has been embedded. And if you remember the previous 7-day forecast, there were also percentages put onto that particular thing. Now, another way is National Hurricane Center. Now, they have their track forecast cone. You might know of it as the cone of uncertainty. That is not the official name of it, but that's okay. And this particular graphic is directly from the National Hurricane Center. So it has the cone, it has the black path, the line that goes through the center of the cone, but then it's also showing color-coded watches, warnings, there's some labels. So it has quite a bit of information in a singular graphic, but it's too much. It's too much information. And if you are a person who is watching this on TV, this would be just overwhelming. So they have to translate this for TV. So here's an example of a TV graphics cone of uncertainty. You've got Tropical Storm Eta, you've got that cone, you've got that center line, in this case in yellow, you've got the spots with the icon of the hurricane, and it's covered up by her arm, but you can see times and information like that. But you've lost the watches and warnings. And so you're losing a little bit of the information about that. And in fact, research on the idea of the cone of uncertainty has shown that the public oftentimes does not understand the cone of uncertainty. The cone of uncertainty causes uncertainty. Oh dear, that's not good. So one of the problems that has happened with it is there are some people who perceive that the outer line, in this case the white line, indicates the edge of who's going to have a problem. So, oh, I live on the A in Cuba, so I'm outside that line, so I don't have to worry about this hurricane. That's not true necessarily. It has the width of the cone of uncertainty has absolutely nothing to do with the width of the storm. And so there is uncertainty involved with that and just people misunderstandings of what the graphic means. So there are efforts that have been made to try to do something different, to try to get it maybe a little bit more understandable or to show the inherent uncertainty. So one such thing is a spaghetti plot. This is a TV graphic, but specifically this was one that was shared on Twitter. Each of the different colored lines represents a different forecast model. That's labeled pretty well, but even doing research on this, the researchers found that people didn't understand what the color coding meant. Wait, what does the one that's on the left mean that it is the most important one? Does the red indicate it's the most dangerous one? All these different things. So even trying to use something that gives more of an idea of uncertainty is not enough to necessarily understand what's going on in the minds of the public. Here's another example of somebody who is actually trying to do a little combination of both. John Morales from NBC6. Again, this is an image that was shared from his Twitter account. But you have your lines, your spaghetti plot, plus the National Hurricane Center predicted center of the tropical cyclone is shown by those red icons that represent hurricane. In fact, there's even little numbers inside those to show what strength is expected. And in this case, when John shared this, he was able to interact on Twitter with someone and explain the fact that, hey, look, at the National Hurricane Center is actually predicting that it's not going to follow just the center of the spaghetti plot. It's actually expected to go a little bit further south, and that's because they think that one particular model has a better handle on this situation, is doing a better job of predicting what's going to happen. So this is a never-ending trying to figure it out, trying to make sure that the public understands it, but really trying to help the public understand that not everything is just 100% cut and dry by showing levels of uncertainty. Another technique, translating numbers to words. Slight risk is 10 to 30% chance. Moderate, 40 to 60, likely above 60. And other words like scattered, isolated, or widespread. That can really help people to understand what's happening with that weather, that precipitation that might be coming. And Dan Breeden, again from WXOW and La Crosse, said, I try to use these in whatever combination best fits what I think will happen. So you can say the 10 to 30 and slight risk. You'll say slight risk of scattered showers or isolated showers, and all of a sudden the public has a different idea about that. Strategy is also combine it. You don't have to use these separately, and that's the power of the TV weather. You get the graphics, but then you get to do that verbal explanation and narrate the story and explain to people what's going on. And that really is a huge appeal for TV. I'm not going to get into the fact that TV meteorologists also have to be online and creating graphics, and that's a whole other can of worms that thankfully I did not have to deal with social media too much. I just had to deal with our website. Finally, final strategy I'm going to talk about is acknowledging and explaining, as we call it in the biz, your bust. There are times where you are going to get it wrong. And that's an opportunity in TV weather to have a conversation with the audience. Oh, I forecasted a high of 90 yesterday. We only hit 72. And you know why? That cold front. It was much faster than we expected. It came blasting through and it cooled us off and it felt great. You can also see here, this meteorologist is talking about how 7-day forecasts are accurate 80% of the time, and then talks about how accuracy increases as time decreases. So just acknowledging that we have busts and then being able to explain them. And that's because there's more of that relationship. We're going to see you the next day. You're going to look at our forecast. And so in TV, that is built in to some degree. Other areas where strategy is involved is looking into other areas of research. So National Science Foundation funds social, behavioral, and economic science research when they're talking about topics like hurricane risk communication, evacuation, recovery processes, because oftentimes when we're talking about weather, we want people to act based on the information that we are giving them. And so the National Science Foundation knows if we want people to act, they got to be motivated, socially, behavior, economics, that type of thing. But it's a complicated setting that we're talking about here because you have your TV meteorologists. They're getting some amount of their forecast from the information from NOAA, but there's also a company that makes the graphics. And if there is not a graphic that does a good job of explaining the uncertainty in the situation, then a meteorologist might have to make it. And they might not have time every single day to make a ton of additional graphics. So that plays a part. You have your researchers. They are in communication. There's NOAA's maybe, or National Weather or National Science Foundation is funding that social behavioral communications, SciComm research, but then the graphics company might be doing their own marketing research. So you have a lot of different things at play when you're talking about communicating in TV. And so I'd like to take from those things that are done in the field of television and say, what does that mean for other people who are trying to communicate uncertainty? So one thing is to use graphics to show uncertainty. Your graphics might not look like the TV weather graphics, but finding ways to bring that into your graphics. Using common language to explain numbers in your writing, but also in your spoken language if you're doing a presentation and you're trying to communicate with others. Telling the story behind those numbers, especially when those numbers are not necessarily what one would expect. Acknowledging that you, and science more broadly, has been incorrect. Yes, science is not the magical thing, this perfection that's always right and it knows everything. Science is fallible, and we need to maybe not put science up on this pedestal because that's a big turnoff for a lot of people. The idea that, oh, science believes it's so much better than everything else. And so science has been incorrect, and here's why. And here's how it changed, how things were learned from inaccuracies. Oh, this idea was, somebody had this idea, it was held for a long time, people challenged it. And then they found that this part of it wasn't working quite as well. And so that's how science gets better and learns more. And that angle of it, I think a lot of people are really missing. They don't understand that side of science. And then looking, especially if you're talking about SciComm, looking to other fields like the social sciences for guidance, techniques that come out of those social science fields, like using frameworks, a lot of things that you may have heard about as a science communicator or in one of your SciComm trainings, are those things need to really be listened to because they have a lot to share with those of us who are trying to communicate uncertainty. So I promised a bonus tip, and this is something for anyone who is trying to communicate science with other people using, say, a map or a chart. Do not say things like, and here you'll see.
Where?
That's the voice that I hear in my head. That is the voice of one of my professors at the University of Wisconsin-Madison.
Where?
John Martin's voice every time would come in, every time I would try to stand in front of the weather map and be like, and here we have a cold front sweeping. Oops, nope. Here in Nebraska, we have a cold front sweeping in. And the reason why I think this is a bonus tip that is useful for anyone doing science communication, and John Martin, if you're interested, is a wonderful science communicator. He and one of the other professors from the University of Wisconsin, in fact, have their own group, the Weather Guys. They're on Wisconsin Public Radio. You can listen to some of their previous shows that they've been on. They also have a blog. John's got a book coming out, so he's all weather communication, science communication. But the thing you need to think about, whether you're presenting virtually, as many of us are still doing, or even once you're back to presenting in person, is that people are distracted and they might not be looking at your presentation. So if you say, and here you can see that this is really an amazing number. Okay, well, I might have been, maybe I'm on a different screen on my device, or maybe I was looking down at my phone for a second and I totally missed it, and then your point is lost on me. So saying things like, here in California, you'll see that the numbers are really high along the y-axis, you'll notice. So those are the types of things to really think about. And I had to think about that, especially when I was a morning and midday meteorologist, because people are getting dressed, they're getting their kids dressed, they're making their lunch, they're letting their dog out to do its thing. So there is a lot of distraction involved. And as we're trying to communicate with people virtually, there's even more opportunities for distraction. So this is a great way to get those messages across that you want to and not have people look up just a second too late and really miss out on what you were trying to say. So as I mentioned before, I have a Google Doc that I created, and I have kept the chat closed because sometimes I find that the chat window leads to all sorts of problems. when I'm sharing my screen. But you can go into this document. I put together a lot of resources. There might not be the resource that you're looking for, though, and I am more than happy to help you out. So you can reach out to me. My email address, I'm on Twitter, I'm on Facebook. You can go to my website, but I just started it, so it's not very good. But I am happy to try to help you find resources if you are looking for additional ones. And we are now to the point where questions.
Fantastic. Thank you, Sarah. I just want to start by saying that I can tell that you're a professional and that you've done a lot of on-air work, because I was listening for ums and uhs and, ers and things like that, and I didn't hear any of them. So a consummate pro, very impressive, and a true example of what to strive for with presenting and with science communication. That was fantastic. We've got a lot of questions. And see, there's an from me, so I'm not quite ready for prime time yet. I'm going to start with the one that came in most recently because it's very timely, and I will read it aloud. It's a bit of a lengthy question, but it's a really good question. So the question is this: as the South deals with possibly bad, severe weather today and tomorrow, and for those of you who haven't seen the weather today, they're predicting high likelihood of tornadoes throughout the South, right? So it says, as the South deals with possibly bad, severe weather today and tomorrow, I'm seeing a lot of people on TV and online posting the storm prediction center maps with severe risk potential categories. The question goes on, I've always thought that these 5 categories, for example, slight, enhanced, moderate, mean different things to public than they would to meteorologists and weather enthusiasts. Namely, they seem much less important and severe to the general public than I think to the SPC. I probably just already read that. I'm going to skip it. So how would you advise we talk to our family and friends about these categories and what they mean, and how we should prepare in response for possibly bad weather?
Absolutely. And in fact, the National Weather Service is constantly thinking about these types of things. Some of you may have heard in recent weeks that some changes that they're looking at doing. One is getting rid of advisories, and I believe that has been formally decided that at some point in time in the next year, instead of having advisories, watches, and warnings, that's too much to confuse people. They're getting rid of advisories. So it is a conversation that National Weather Service is having. And I think part of it is dependent on how you use color. People get messages from color. And so when a computer graphic is designed to have maybe a green for the slight, a yellow for the moderate, and a purple or a red for extreme, that subconsciously sends messages to people to take something more seriously than they might otherwise. And so that is one way. There's a lot of subconscious messaging that goes on in how computer graphics are designed. And there is research on that if you're looking for it. I think I might have put in 1 or 2 articles about it. But I think that the most important thing is to really hone in on where they're forecasting the biggest, most extreme problem. And they really do trial runs with what their language is, whether you say extreme, whether you say high, those types of things, and hone in on where you see those highest values and those reds and those purples and those types of things to try to make those people the most aware of what the risk is. Hopefully that answers it somewhat.
Yeah, no, I think that did. And related to that, we've got another question in chat, which I think follows up on exactly what you're talking about with visuals and graphics. So I'm going to read this. Part of the challenge with the National Hurricane Center's cone of uncertainty is also that it isn't based on the spaghetti plot, but historic accuracy. What role do you think prior experience with graphics plays? I'm thinking about how people have probably seen weather forecast graphics before from TV weather stations, et cetera, and have developed an understanding of what these mean, whether or not their interpretation matches the creator's message. So I think that's kind of along the lines with what you're saying, but can you elaborate on that a little bit, sort of the historical precedence of visuals in weather forecasting?
Yeah, so a couple of different things from research. One is that people if you give them choices of how would I like to know the probability of rain, for example, and this comes from one of those articles that I shared in my document, people like familiarity. And so when they gave them the option of hearing that there's a 20% chance of rain, a slight chance of rain, 2 out of 5 times, and gave like the odds as if you were in Vegas, that sort of thing, people are drawn to what they've seen before. So they liked hearing 20% chance of rain because it's what they've seen before. So there's that first thing. Familiarity makes people more comfortable. Other things that are not explained, and I had slides on this, but I pulled them because I knew I was going to go too long if I didn't keep them in, is the idea of normal. So when we're talking about normal, if you've ever seen your almanac page in their weather graphic, or you've ever seen someone talking about the average high for today is 72, and you wonder, well, average over what time period? What they're really looking at is a 30-year time period, and they get updated every, I believe it's 10 years to the next 30-year time period. And so those numbers, it takes a while for bigger, broader patterns of what's going on to change. Another thing that the National Hurricane Center is talking about is changing the start of the hurricane season for the Atlantic. They're talking about moving it up 15 days based on what they've seen over the last 10, 20, 30 years, that there are more named storms that are happening even before the season begins. And so there are constantly these conversations about, okay, when do we make these changes to what is now normal? And when we have this climate change that's happening at an accelerated rate, we also need to think about how each year, in the past, when it wasn't happening as rapidly, waiting 30 years wasn't a problem. I have no idea. This is just me speaking on my own, but with the rate of change happening more quickly, I wonder whether there's any conversations about maybe we need to make those changes happen sooner when we look at things like averages. But that is beyond my actual knowledge. That is just me speaking theoretically.
Great. So that actually is a perfect segue to the next question I was going to ask, which is about climate change. So my colleague Misha Angrist asked the following question. About 10 years ago, there was a survey of meteorologists about climate change. Only 24% thought humans were responsible for most climate change over the prior 50 years, and 29% thought climate change was a scam. Why do you think so many have responded that way? And do you think the results would be dramatically different today? And I'll just mention as an aside that there's a pretty well-known case of probably the most popular local weather forecaster here in the North Carolina and the Raleigh-Durham area, Greg Fishel, who was well known for years to be a climate change denier, and then more recently saw the light about climate change and has become an outspoken proponent of teaching about climate change and acknowledging it.
Yeah, I think it's a really I do think that if you did a survey now, that it would be different. I very strongly believe that, but it is based on my own personal interactions. I had a chief meteorologist that I worked with who had questioned what climate change, what level of involvement people had with climate change. And even I myself, when I first got into it, was like, maybe the researchers don't have a fully formed idea. A big part of that, I think, is that a very successful effort on the part of a number of the different fossil fuel industries to put out messaging that just kind of put those questions in people's minds and said, okay, well, sure, we know that it's changing. We'll give you that. But how much are people really causing it? And I think that there has been a counter effort by the scientific community to say, wait, no, there is not nearly as much disagreement as people are trying to make you think for us. And so Meteorologists are not necessarily people who have advanced degrees in atmospheric and oceanic science. In fact, some of them don't have any degree at all. Al Roker didn't go to college to become a TV meteorologist. But there are opportunities as meteorologists to have continuing education. Oftentimes the TV meteorologists have fairly good relationships with their local National Weather Service office. In fact, they have a chat room open so that a TV meteorologist, if they do have questions, can reach out to the National Weather Service. And many of them are members of different organizations like AMS, the American Meteorological Society, and NWA, the National Weather Association. And they have yearly conferences and opportunities for them to learn about kind of the latest and greatest research. So those who are not necessarily following those things are going to be swayed the same way that the general public is moving. And so I think we've seen a move in the general public to more people believing the greater and greater role that humans are playing in climate change. And I think you're going to see a shift somewhat mirroring that in TV meteorologists.
Great. Yeah, that's certainly something to keep our eyes on, I think. Since you mentioned training and preparation for becoming a TV meteorologist, actually one of the questions I wanted to ask you was tying back to the theme of this webinar series, which is Science Communication Lunch and Learn. Do TV meteorologists or future meteorologists, when they're receiving their degrees, get any sort of formal training in science communication that you know of? I'm sure they didn't 10 years ago, probably, but now that there's a lot more consciousness about science communication training, do you have any sense, do you keep sort of tabs on what meteorology programs at universities around the country are doing, and does it ever include any sort of training in science communication?
Yeah, well, I think it really varies depending upon the program. Some programs are really known as broadcast meteorology programs. So the people who are in those programs are entering them explicitly because they want to go on TV. Everyone else in the program is interested in being on TV. And then there's other programs like the program I went to at UW-Madison. It was Atmospheric and Oceanic Science Department. And it was a mixed bag. So my department, or the people who were in my undergraduate classes, were a mixture of people who went into industry. I had a number of people who are ROTC because the military has a lot of need for people who are meteorologists. But I think one thing that is kind of inherent in the field of meteorology that's a little different than a lot of other fields is, again, the fact that we are putting together forecasts in a lot of jobs as meteorologists to actually inform action by other people. I have a friend who worked for a company that made wind field maps so that they could decide where to put wind turbines. There are people who work for insurance agencies to try to figure out what rate should we set based on the risk that an area has for severe storms. And so because it's a field of science that is really directed towards communicating the knowledge to the public, in my classes, we had to do reports where we would stand up and we would talk in front of a map and gesture and do all that sort of stuff. We didn't have a green screen, but we were still talking in front of a map and doing presentations pretty regularly. John Martin was sitting there saying, where, pretty regularly. And so because you're doing that practice a lot and you're seeing other people presenting and you're watching the feedback that they're getting, you get aspects of it. But I would imagine that some of those programs that are truly broadcast meteorology focused probably have additional things that they do, but I'm not familiar with those programs myself.
Yeah, that's really interesting. And just as an aside, University of Wisconsin-Madison also has one of the top science communication programs in the country. I mean, some of the top people in the world are based at University of Wisconsin-Madison. So I wonder if there have been conversations about trying to connect those two programs and bring more science communication training into the meteorology program. That'd be interesting to look into. Yeah. So another question that I think is really interesting that I want to get your feedback on now was submitted to chat. And the question is the following: has there been any effort to express a confidence level in forecasts in addition to probabilities?
Yes, but it is kind of a case by case basis. I think it's something that inherently meteorologists do when they're on TV and they're telling the story, because explaining the confidence is part of your story. My example, especially about when you have that cold front coming through and you're not sure when it's going to come, or maybe you have that low cloud deck in the morning, it's super foggy, and as soon as those clouds burn off, man, those temps are just going to go rocketing. Or you have specific types of things coming through, like thunderstorms, like thunder snow. As a meteorologist, as I'm telling the story, that's when I'll put that confidence in and I'll speak about it. And some meteorologists have chosen to create graphics that really show what that level of confidence is. But there and that slight, moderate, extreme risk of severe weather is an effort on the part of the National Weather Service to maybe give a little bit more of an indication of that confidence. And those types of things can very easily be made into graphics for TV. The fact that you have graphics, you don't remake every single graphic for every single show that you do when you're on air. You have your preset show, and then you pull in additional graphics, and some of them are pre-made graphics. And when you have a pre-made graphic that does a really good job of explaining uncertainty or confidence, it's a lot easier to pull that in and plug it in, and it automatically updates in the background and you don't have to do any more work, versus if you want to talk about uncertainty and make your own graphic. So again, that time comes into play, and just how lazy you might be feeling when you got up at 2 a.m. and you went to bed at 10 p.m. because the neighbors were really loud. I might not feel motivated that morning to create a graphic to explain that sort of thing. So there's that interplay of graphics and the companies that create those graphics that adds an extra layer of complexity here.
Yeah, those morning hours have to be rough. That would quickly talk me out of any career in morning meteorology. Earlier in your presentation, you said something towards the end about the idea of helping educate the public towards the notion that science is fallible and that it's not perfect and that it's a process. And certainly we know within science communication training that a lot of times part of the problem is that the public doesn't really understand the process of science fully. We're seeing a lot of that with COVID, I think, as well. But I'm wondering, is there a tension that exists between this idea of helping the public understand that science is fallible, while at the same time, at least it's my sense, that there's sort of a constant effort within the meteorology community to convince or communicate to the public that meteorology itself is a legitimate scientific field, and it's not just sort of throwing a dart at a dartboard and making a prediction based on that. So how do you handle the tension between communicating science is fallible while at the same time letting them know that you're not going to predict everything accurately all the time?
Yes, that is absolutely a conversation that is had. I think it is very much about personal. So I mentioned before that I am on TV, and when I was in the morning and midday, there were regular viewers who watched every single morning, from the 7 to 7:30 a.m. while they ate breakfast and they got their lunch packed. And every day they saw me talking about what the weather was, talking about the latest thing going on in my life. Maybe they met me when they went to the Iowa State Fair, all those types of things. And they come to trust me as a person. And it is very much a relationship, even though I have never seen them, or maybe they've shown up and shook my hand, or maybe they've sent me creepy emails. There's a few of those people. But there is this trust that TV meteorologists have with their public. And the people actually from the federal government and emergency management people take advantage of that trust and use TV meteorologists to share information about evacuations, about where they think the worst of the storm is going to be, about where resources are for people because of flooding, that sort of thing. And so it's a very unique case where the trust is between you as a viewer and me as the meteorologist, or my TV station's weather team. And so if you trust me as a person, then if I say, so I want to show you a few things that could really throw a monkey wrench in this. Or if the next day after I got the weather forecast wrong, I say, oh man, it was one of those brutal days where we totally messed up yesterday. And sometimes the chit chat between the anchor and the meteorologist actually allows for that opportunity for them to play the role of the public and be like, man, I had my picnic yesterday and I got rained on. You said there was a 20% chance. Oh, well, yeah. Well, it was 20%. And so I think that there's that really unique relationship that meteorologists have to that. If you trust me as a person, then if I say there's uncertainty, you're not distrusting me as a person. You're trusting that I'm telling you that there's uncertainty. Does
Really
that make
interesting.
sense?
Yeah, really interesting. Thank you. Yeah, it's interesting the notion of trust in an area that's so potentially inherently fraught with uncertainty. That's an important conversation to have, I think. We are running out of time, unfortunately, and I think we have time for maybe one more question. So I'm going to exercise moderator privilege and ask my own question, because I've always sort of wondered this. You did when you were on the air, I think you were mostly based in the Midwest, that correct? Where
Yes.
you actually have weather, right? Now, I spent the first 28 years of my life on the beach in Los Angeles or San Diego. That's where I grew up and went to college. And we don't have weather, right? The forecast year round is 73 degrees and sunny, right? And I'm not complaining. It was wonderful to live there. But I've always wondered, is it considered a better gig for a TV meteorologist to be in a place that has actual exciting weather to talk about? Or does everybody want to be in San Diego because, it's San Diego and it's so pleasant year round?
I think TV meteorologists in general are adrenaline junkies. And we get really excited when there's severe weather. We sometimes have to temper that excitement because it can be like, oh, there's a chance of tornadoes today. But we're not going to go on the air and say that because, tornadoes mean damage, injury, all sorts of things that are very negative. But we are so intrigued by weather and what happens and really driven by keeping people informed and keeping people safe. And that's why it's so frustrating as a TV meteorologist when you get all these angry messages you cut in and talked about like the tornado that was hitting 7 miles away from me. And I was watching the Bachelor season finale. Or I had people who got mad at me because in Iowa, there is a town, Nevada, Nevada, Iowa, and I mispronounced it when telling them that there was a tornado warning. And so there's a level of frustration involved with that, but we are junkies. We're into that weather when it's happening, because if it's not happening, it's not really weather. It's just like
San Diego.
Sun. It's just like San Diego, exactly. How I'm going. And then you have to find other things.
I don't really remember ever checking the weather when I lived in San Diego, right? There were two things I had to learn when I moved to North Carolina. I had to buy long pants because I didn't own anything but shorts. And I had to learn to start checking the weather before I went out because it actually mattered. So,
and those meteorologists probably didn't get the TV meteorologist's least favorite comment, which is, if I could be as inaccurate as you are and still get paid, ha ha ha. The science, the math tells you that you are wrong. Do not say that to a meteorologist. Don't call a woman on TV a weather girl unless you call them weather boys. Just a few other pet peeves. Yeah. Okay, I got that off my chest. I feel better.
Yeah, no, good tips to fit in at the end. We are out of time, unfortunately. Sara, I want to thank you. This was wonderful. We got lots of great questions. So I want to thank all our audience for being here and for asking great questions. I do want to remind everybody that we have one more SciComm Lunch and Learn next month, April 15th. I put information in chat all about it. It's going to be a really cool one. We want you to submit your science poetry before next month's event, and we may invite you to read your poem on the air. But thank you all for tuning in, and thanks again, Sara, for being here. It was terrific. Have a great day, everyone. Hope to see you next month.